Hello, good morning and welcome to all of you. This is Rajesh and I am here to present a new lecture on the water stress. So friend, this is a very important topic for all the competitive exams, and in this lecture we will discuss about the different aspects of the water stress, such as what is water stress or drought, and we will also discuss about the types of drought. Then we will discuss about the SPAC system, and final, in the end, we will discuss about the development of water deficit, that how the water deficit condition developed under the soil. So let's start our discussion with the water stress or drought. So water stress can be defined as the absence of rainfall or irrigation for a period of time that is sufficient to deplete the soil moisture and causing the injuries to the plant. So water stress or drought can be defined that there will be an absence of rainfall for a long period, or there will be a less irrigation for a period of time that is sufficient to deplete the soil moisture and causing the injuries to the plant. So this is the definition of water stress or drought. And then the supply is determined by the amount of water held in the soils to the depth of the crop system. So you know that water, there will be a supply of water, and there will be a demand of the water. So the supply is how the water supply depend, that how much water is available. So water available in the means what, how much amount of the water, how much amount of the water is held or hold by the soil, which is available for the your root system, that is the supply. Okay, and the demand of the water is set by the plant transpiration rate or crop evapotranspiration. Okay, which include the both transpiration and soil evaporation. So in the supply, what we discussed, that how much water is held by the soil and how much water is available for the root system, for the transport to the shoot system. And how we can define the demand means, uh, how much there will be a transpiration, means when there will be a transpiration, there will be a increase in the demand for the water. And the second process is the evaporation, soil evaporation, means under the high temperature there will be a evaporation of soil, water from the soil. Okay, so they increase the demand. Okay, then transpiration causes the leaf to cool relative to the ambient temperature. So the why this transpiration is crucial, because you know that plants are sessile in nature, they cannot move from one place to another place. And when there will be a high temperature, so plant temperatures, plant canopy temperature also increase. So in this condition, plants have a specific mechanism that is known as transpiration. Okay, through the stomata. So they reduce the energy load and cool the canopy surface. If there is no transpiration, then there will be a possibility that leaves could be heated to killing temperatures. Means If the temperature is increased very high, if there will be a closing of the stomata or there will be a no transmission, then there will be a possibility that leaves could be heated or can be clean. Then we will discuss about the what is water shortage. So water shortage can be defined that it is caused by the climate change. Okay, so water shortage caused by the climate change, such as altered weather pattern, means there will be a less rainfall, or there will be a change in the rain intensity or duration of rainfall. Okay, also increase the pollution, such as increase the water pollution and increase the human demand and overuse of water. So these conditions accelerate the water shortage. Okay, so I think you understand that what is water stress, definition, what is the demand and supply of the water stress, and why this transmission is required for the plant. Okay, and then what is water shortage. And a country is below 1000 cubic per meter per person year is called as a water stress. Means in any country, if a person is getting 1000 cubic of meter water, less than 1000 cubic meter of water per year, that is also known as water stress. So water is driven through the plant from the soil to the atmosphere by the difference in the water potential. So friends, you know that moves water moves through the difference in the water potential. Okay, means water moves from the high water potential to the low water potential. Okay, so soil have high water potential, then your root cell, water moves from soil to root, and root to xylem, xylem to shoot tissue or leaf, leaf to leaf surface, and then finally it is in atmosphere. Okay, so atmosphere have lowest water potential. So there is a system of water movement that water move from the soil to the your atmosphere. Okay, so water is driven through the plant from the soil to the atmosphere by the difference in the water potential. Means soil have high water potential and atmosphere have very low water potential. Between the atmosphere, that is very low water potential, and soil relatively high potential. Okay, and the flow of water is also influenced by the hydraulic resistance in the plant. So friends, you know that there are so many types of resistance are present in the plants. Like there is mesophyll resistance is there. Okay, there is stomatal resistance is there. Stomatal resistance is there. There is xylem resistance is there. Xylem resistance is there, and also there are so many resistance which lower the flow of the water. Okay, so the flow is also influenced by the hydraulic resistance. Means if there is high resistance, then there will be a less flow. If resistance is low, then there will be a high flow. So resistance regulated by the stomatal resistance or by the conductive system like root and stem xylem elements, and by the resistance of cell and cell wall between soil and the root xylem vessels. Means different types of cell wall, xylems and stomata create a hydraulic resistance, means which way they regulate or reduce the flow of the water. Even sometimes cellular membranes can also regulate the flow of the water through the protein known as aquaporins. So next lecture we will discuss about that. What is aquaporins? Okay, so you got about that. There will be a water moves through the difference in the water potential, and soil have very high water potential compared to the atmosphere, and there will be a interlink between the soil, root, stem and then atmosphere, and also the water flow is regulated by the hydraulic resistance and different elements of the plant like root cells, stomatal conductance, stomata and your xylem is uh, regulate the flow by the resistant. Okay, so even cellular membrane having the aquaporins which increase the flow of the water through the aquaporins. So this is about known. Now come to the types of drought. So drought can be mainly defined classified as the four groups. So first one is the meteorological drought. So we will define the meteorological drought in the form of precipitations or rainfall. Okay, so it is defined as there will be a lack of precipitation over a region for a period of time. Means if a region receiving the rainfall, it could be 75% less than the normal, 25% less than the normal, 50% less than the normal, then they defined as the your meteorological drought. Also the regions are also defined like tropical, semi-tropical, temperate, and these regions are defined according to this. Then hydrological drought. What is hydrological drought? Means period with inadequate surface and subsurface water resource for water use of a given water resource. Means this is the period with inadequate surface and subsurface water resource. Means a there will be a high there will be less water for a period. Means soil surface and subsurface water resources have less water. Means whatever of the water present in the soils in the form of surface water or subsurface water which is less, that is known as hydrological drought. And what is agriculture drought? Means period with decline soil moisture and so consequent crop failure without any reference to surface water resource. May be possible that there will be a available surface water, but this water is not available to the plant. So there will be a decline in the soil moisture and there will be a consequently failure of the crop is known as agriculture drought. And last one is the socio-economic drought. So this drought is measured in the term of socio-economics, means for the economic goods. So this is defined as the associated with the failure of water resource system, means there will be a failure of water resource system to meet the water demands and thus associating drought with the supply. Means there will be a imbalance between the supply and demand of the water. So it creates the socio-economic drought. So friends, there are four types of drought. Meteorological drought means there will be a lack of precipitation. Hydrological drought means there will be a less surface or subsurface water resources. Agriculture drought means crop there will be a decline in the soil moisture and subsequently causing the failure of the crop. Socioeconomic drought means in any region there will be an imbalance between the water demand and supply. So it is known as socioeconomic drought. Okay. Now come to the SPAC. So SPAC is the soil, plant, atmosphere, continuum. Okay. So this is the pathway of water movement. Okay. So water movement through the first in the soil, soil to the root to the shoot or plant, and out into the air or atmosphere as a series of closely interrelated process. Means these are all the soil, plant and air are connected and they are closely interrelated, called as a SPACs, defined by the Phillips 1966. It is useful in the emphasizing the necessity of considering all the aspect of water relations in studying the water balance of plant. So the spec is important to the study the water balance of the plant. The low water potential of atmosphere, already discussed that atmosphere have low water potential and relatively higher water potential inside the leaves lead to the diffusion gradient. Means there will be a generation of diffusion between the leaf surface and atmosphere, because this leaf have high water potential and your atmosphere have low water potential. So water move from the high water potential to the low water potential across the stomatal pore of the leaves, and that drawing the water out of the leaves as a vapor, because that in the there water is in the pressurized water in pressure, and there will be some resistant force. Okay. So the leaves have high water potential, atmosphere have low water potential, and there will be a generation of diffusion gradient. So water moves from high to low via this diffusion gradient, and your resistant uh, reduce the flow of the water or regulate the water flow. As water vapor transfers out of the leaves, means after the transpiring of water from the leaves, further water molecules evaporate of the surface of mesophyll cells to replace the lost molecules. Means there is a diffusion gradient, and all the water from the your root cell to the leaf surface, they are connected, and if a water molecules lost by the means a water is transferring, that second molecules from the mesophyll cells replace and come to the leaf surface. Okay. So since water in the air inside the leaf is maintained at saturation vapor pressure, means they are maintained at saturation, means they are connected. Then water lost at the surface of the cell is replaced from the xylem, and from mesophyll cells it comes from the xylem, and here there will be a cohesion and tension property. You know that cohesion force means force between the or attraction between the same molecules, like water molecules, and adhesion. Okay. So water xylem plant pull additional water molecules through the xylem from the root toward the leaves. Means the system is that from the root cells to the leaf surface, your water is in the a series or continuous water is there. So if a water molecules lost from the leaf surface, then the next water molecules by replaced by the next water molecules. So spec system is analogous to flow the electricity described by the Ohm's law. Means how we can define that the flow it defined what as a difference in the water potential upon the resistance. Like if we will define the flow between the soil and root surface. So how we will define that water potential of the soil and water potential of the root surface. So soil have higher water potential than the root surface. So water potential of soil minus the water potential of root surface upon the resistance of both soil and root surface. So this defines the flow of the water from the soil to the root surface. Like this, the flow from the root surface to the xylem means water potential of root surface minus the water potential of xylem upon the resistance of both root surface and xylem. Like this, the water potential of xylem minus water potential of leaf cells upon the resistance of xylem and leaf cells. Then we can define the flow that conductance of leaf minus conductance of air upon the resistance of leaf and air. So by this term we can define the flow of water from the different tissues from the soil to the your atmosphere. And what are the factors which regulate your spec? So first is the driving force. So who is the driving force? Means difference in the water potential or sunlight or vapor pressure deficit. They regulate the your spec system. Also the resistance of the different tissues. Then also soil temperature, leaf temperature, and closing and opening of the stomata regulate the spec system. So we can understand that these are the water potential of the soil, root, xylem, leaf xylem, and leaf cells. Means soil water potential is minus 0.3, and what is leaf cell have minus 1.4, and means soil have high water potential, then root cells have less water potential than your soil water potential, then root xylem have less than this root cells, then leaf xylem have less than the root xylem, and leaf cells have less than, and environment atmosphere have also very less of 5 megapascal or it may be less. So like this water moves from the soil to the leaf cells. And soil water potential is negative because of the surface tension effect of the numerous air liquid interface in the soils, and this water potential also vary with the rainfall and wilting conditions. So this is about also the xylem to leaf water moves partially by the apoplastic. You know there will be two types of water movement, that is symplast. Symplast means there will be a living cells are involved, and apoplastic means water move from the cell wall or that some pores, okay, and partially symplast. The water in the cell wall pores is in contact with air where evaporation can take place. So in the cell wall pores, there will be a pores is available on the cell wall, so there evaporation take place. Transport of water along pathway occurrences. So for the transport of water, there will be a soil physics are involved, means soil tension pressure. Then physiologically diffusion pressure deficit is involved, and meteorological relative humidity and vapor pressure involved. So this spec is the physics, physiology and meteorology, all three science are involved. In the soil and the xylem liquid, water moves by the bulk flow. In the mass flow or bulk flow, in response to the pressure gradient. So in the soil and xylem, liquid water moves by the bulk flow. When liquid water is transported across the membrane, means such as osmotic flow occurs when cell absorb the water and when root transport water from the soil to the xylem. Means in the cells, water flow is regulated by the osmotic pressure, because in the cells there are some metabolites or salt are present which increase the water tension. In the vapor phase, water moves primarily by the diffusion, at least it due to the outside air. Or in the vapor last phase or vapor phase, water moves by the diffusion. So in the soil, it move by the soil and xylem, it move by the your bulk flow. In the cells, it's moved by the osmotic flow, and in the vapor phase, it moved by the diffusion. So this is the flow of the water. So this is about the spec. So simply spec is a system which describe that how the water moves from the soil to the atmosphere. What are the how this is move into the soil and different tissues, and how water potential regulates, and how resistance regulate this flow. So this is about the spec. Now come to the development of water deficit. So already discussed that plant water deficit developed as its demand exceed the supply of the water. Means when the demands of the water is higher than the supply, then there will be a development of water deficit conditions. And the supply is determined by the amount of, already discussed that amount of water held in the soil to the depth of the crop system. Means supply, what is supply? Means how much water is available for us and how much water is available in the soil. That is the supply. And the demand is defined by the how much transpiration rate and how much is the evaporation, evapotranspiration and transpiration is there. So this define the demand. And evapotranspiration is driven by the crop environment as well as major crop attributes. Means plant architectures like leaf area, plant development stage also regulate the evapotranspiration. Okay, the plant function within a physical system consisting of the soil plant, that is spec already discussed. And during the day, plant is under heavy energy load consisting mainly of the solar radiation, ambient air temperature and humidity. Okay, so means in the during day that plant have high temperature, high solar radiation, so there will be a high energy load, so more deficit water deficit condition during the day times. So you can understand that how this water deficit condition is available. Means this is the profile of soil profile. Means earlier if there will be a sufficient rainfall or irrigation, then the soil is in the saturate condition. Means there will be a 100% water is held by the soils. All the your macropores or micropores are filled by the water. This is known as also as bed soils. And then after 20 or 40 hours, there will be a filled capacity conditions. Means there will be a available water, which is important for crop growth and development. and continuously, if there will be a no rainfall or no irrigation, then there will be a depletion of your available water. So after some days, like 20 days, that water from reaching to the permanent wilting point. So in this condition, there will be no water available for the crop growth or development, or what plants are not able to mining the soil water. So this condition is known as permanent wilting point. So this is the about the development of water deficit, means how the water drain and these conditions are created. Also this graph, this is the soil water potential and this is the leaf water potential. So this is the days after irrigation, you can see. So this is the day of rainfall. So at that day, there will be a high water potential. It can be near to the zero, and continuously there will be a depletion of soil water potentials. And you can see at day, and this is the leaf water potential. Okay. So here you can see at day there will be a -3 megapascal. But after that, there will be an involvement of osmotic pressure and resistance, means closing of stomata. So at 16 day, there will be a decrease in the only -1 megapascal. Means in the leaf water potential, there are certain factors like osmotic pressure and resistance which maintain your like turgor pressure and transmission. Both are crucial to regulate your available water or maintaining the water in the leaf. Now, what are the factors which are regulating the water deficit? So, first is the inadequate supply of the irrigation, and second is the means we are not giving the proper irrigation. Okay, then more groundwater depletion than recharge, means more water is depleting, high evapotranspiration and vapor pressure deficits, and no doubt climate change because it's changing the rainfall intensity pattern. Okay, also duration. Then soil property, means your soil is clay type or sandy soils, because sandy soils have less water holding capacity. Then critical growth stages and length of growing period, means if these stages are more water required. Okay, length of growing period, if length of growing period is more, then water requirement is also more. Geographical differences, means it is also dependent upon latitude and altitude, because different regions have different atmospheric conditions or weather conditions, and less rainfall or altered rainfall pattern. So these are the factors which regulate your water deficit. So friend, in the today lecture, we discuss about the basics of drought, that what is the drought and what is demand and supply of the drought. Then we discuss about the types of drought. Then we also give some insight into the how the water movement from the soil to the plant to the atmosphere, and how these water deficit conditions are available. So hope you understand, and thank you very much.